on the question of how psych is progressing, I've read some papers from them recently, and I've always thought that what they were missing was procedural knowledge. And it seemed to me that they're starting to implement lots of different procedures for domain-specific kinds of working stuff out fast. And that was a big step in the right direction. Can you comment on that?
Sure I can. So my work, over the many years that I've done programming, a lot of it is maintenance. And the psych code base is large. It's well over 1 million. It's well over 1 million statements, and I've done maintenance in nearly every part of it. So the procedural parts that the question addresses has to do with making inference faster. So psych attempts to perform deep inference, which is anything over about 3 backchains. And 4, 5, 6 backchains in a theory that has many rules and many facts can be very lengthy to answer. So for example, for subsumption reasoning, rather than use modus ponens or some more general inference technique, so-called heuristic level modules are written. So they've done them for subsumption reasoning, for temporal reasoning, for chained conclusions like connect the dots to prove that some letter that was found in the suitcase might have given a clue to Al-Qaeda's plans for 9/11. So you're right in that psych is starting to think about procedural knowledge, but it's embodied primarily in programs that programmers write on a one-off basis. The main distinction between my work and the work of perhaps some others here in cognitive architectures is to try to represent procedural knowledge in the same way that every other knowledge is represented, so that it'll lead directly to recursively self-improving systems if a system can understand enough about the domain, algorithms, and so forth. I think it's a very good question. It hits right on my major criticism of what psych is doing. Now, understand that their emphasis on fact entry is what it is. I mean, that's primarily what they're doing, and they will be doing as long as the sponsors keep them headed in that direction. Any other question? Next question.
Hi, Brian Gold from MIT. This is mainly targeted at Arthi, but also if anybody else in the audience wants to get on it. So I really like the idea of integrating different parts of cognition, using everything you know to help disambiguate the sentences that are thrown at you. But I'm surprised that you're using a default logic for that. It seems like something that involves numeric weights, ideally probabilities, would be the best way to combine the different sources of evidence that you're getting. Have you thought about that, or is the default logic working for you?
Yeah, actually, this talk is a year old, so that was just a motivating factor to show that how things integrated can help us disambiguate, which is something we just didn't think about when we were building the system. So yeah, if I only have 5 levels right there, and for 5 senses, and if the semantics, all of them have weights to them too, and it gets very hard to implement using default logic, because when I say that it's not one option, I have to just completely not come back to it again, which I don't want to do. And so obviously we've moved into a completely different system where we have weighted constraints now, and we solve them using, we're implementing DPLO, and so it's kind of, we're very inspired by Markov logic work done in Washington. And so it's based on mental simulation. It's more cognitively possible too. So all DPLO does is it picks something that's uncertain, assumes either to be true or false based on prior about which one would give us an answer. And so which is kind of thinking about a scenario or a mental simulation in that sense. So yeah, we have been doing a lot of reasoning work the last year, and primarily inspired for language, because I wanted to use it on cooler grammars with a lot of weights on them, and eventually that led to different advantages too. So one of my other colleagues, he works on time. So in polyscheme, every proposition is tagged by a time and a world in which it's true. So when we say it's true at time 1, and there's no other thing to default to override it, it should be true at every other time following T1. And have to copy that every time is just humongous overload. And so time is actually an essential substrate element in the sense that it's part of the proposition itself. So in that case too, all we have to do now that we have the number of weights there is say that anything that hasn't changed is not likely to change with a weighted decay to it. And so change minimization is there too. So if something is blue, if an object, a car is blue, and it's green at a later time, given that we know nothing else, it's safe to assume that it changed from blue to green and not from blue to red to green. So those all come out of just weighted constraints. So something I started with for language eventually ended up being used for time and change minimization. So the substrate is very powerful that way. So any change one person makes, everybody else can leverage on it too. And so, the social simulation about thinking about another person's mind is similar to the DPL concept, where we think of whether it's fact being true, what happens. It's similar to what if he is blind, kind of. If you're trying to simulate the person who's different from you in the sense that he's blind and you're not blind. So all you do is you think everything about you is same except for that one fact. And whatever you infer from that fact overrides your default belief. So your knowing of light will be overridden because you can't see is a premise in this world. So yeah, there are a lot of ideas like that.
Let's see. I think it's here. You mentioned Walter Kinch, his model, construction integration model. And by the way, he's going to be speaking probably right where you're sitting in July for our Society for Text and Discourse meeting right here in Memphis. And I encourage anybody to attend that meeting who wants to. It turns out the folks in this society, Society for Text and Discourse, have been studying what inferences are made during text comprehension for about 30 years. And we have a pretty good idea about that. Walter Kinch's model is very much the dominant model. And one of the challenges is scaling it up automatically. And that's almost there because of the latent semantic analysis, which probably many people have heard. From large corpora text, you could have the whole web if you wanted to. And he can automatically draw links between words in his construction integration model. And then you take a standard parser. Word dependency parsers are probably the most. Lynn has a model that's the one he uses. So you can go a large distance in really doing this in an automated way in real time. There's two things it lacks, however. One is the mental model of the other person. It doesn't do that, and it's not clear it'll be done easily. And the second, these kind of strategies to keep you on task. Because when you run the simulation with construction integration model, you're kind of like stimulus driven a lot. And to have it coordinated over a longer series of span of time, those heuristics and structures aren't in there yet in an automated way. But that's a great model to be working with.
So I'd like to respond to your excellent point with my question. If you were going to proxy Dr. Kinch, I would ask him in your place, has he given any thought to the other side of natural language processing? Because the theory that I'm looking at least the grammars are reversible. And the question would be, given a set of propositions and the belief state model of the person you're talking to, you know what propositions you want to subsequently appear in that person's mind. How do you formulate a text string that contains that? So I was wondering if Dr. Kinch gave that any thought.
Just quickly, he has done it in... Yeah,
okay.
I pressed it again, but it's not coming up. I think somebody else pressed it.
Oh, I see.
But that's
Go
okay.
ahead.
I'll talk loudly. He's only done that once, and that's actually a model of programming. And where it's a very procedural-based model. But he's done it once, but it doesn't scale up to any arbitrary proposition composing it. It's an interesting question.
Intuitively, that was the approach I wanted to take and do a discourse planner.
Yeah.
And then flesh it out using something like the inverse of construction integration.
The grammar, the similarity we talked about So besides social cognition, language parsing is very similar to planning too. So in that case, you have a higher level goal, and you're trying to express a fact. And your lower level goals are you put them in different phrases, a noun phrase, a verb phrase, and
Yes.
right. So that's how we derive that tree.
This is basically research that's already been done, and we just have to adapt the best of it as we find it. Great. Next question, up here, was it?
Oh, that's me.
Okay, great.
Yeah, my question actually pertained to your comments way back at the beginning of the discussion session, where you were talking about how your system represents procedural and declarative knowledge in kind of the same format. And I thought that was interesting because we have explicitly not taken that approach.
Well, let me say they're encoded in the same format. So on one hand, I can take a Java object and represent it as a sort of a semantic network,
Right.
where the nodes are the objects and the links are the fields in the object. But when I talk about representing a program, the straightforward way to do it is just take the abstract syntax tree and just persist that to a triple score. But that's sort of the dumb way to do it. The idea is that we talk about automatic program synthesis or automatic programming. The idea is that you want the system to have a deep body of domain knowledge about whatever it is the application is going to be synthesized. And it has to have a knowledge of the algorithms. That is, what's a sort? What does it mean to display a sum of numbers? What's a cell in a spreadsheet? And that knowledge, I think, is the algorithmic knowledge combines with the body of knowledge for the specific domain to compose an abstract syntax tree, maybe with successive refinement. And I built a toy model of that when I was at Psychor. I used some of the government funding for our participation in the demo project that DARPA agent markup language, which became the OWL language later on. But no, I don't mean to say that procedural knowledge is stored the same way as facts. It just means that ultimately it's persisted that way.
I see. So the way we've done it in Novamente is we have, and I'm curious to understand how different it really is from what you're doing, although we describe it differently. Because we have basically three kinds of knowledge, which would be declarative knowledge, which is represented in kind of probabilistic nodes and links, which is sort of like a especially probabilistically weighted version of any other logic knowledge representation. We have procedural knowledge, which is represented in little program trees. It could be viewed as being like list programs with a special set of primitives. Then there's knowledge you could think of as experiential or episodic, which is kind of like little internally stored movies of stuff that's happened in the world. And you can convert between any one of these kinds of knowledge and the other ones, but converting can be more or less difficult to do in a useful way. And there's some operations that really want to act on the program trees, or want to act on the experiential movies, or want to act on the logic. So why you can convert between one and the other is only sometimes is that actually an intelligent thing to do. Often, if you take a procedure for hitting a tennis racket against a ball, I mean, turning that into a set of logical propositions may not often be an intelligent thing to do, even though in principle there's code that will do it. I mean, how different is that from what you're describing in your system?
I think it's very similar to that. The idea is that I have not implemented the storing of procedures, and I'm tempted severely to come up with a greatly simplified version, say the Java programming language, in order to kick this thing off. But years ago, I did write a knowledge-based implementation, and I was able to easily persist Java syntax trees in it, and you can read it Java to persisted propositions and back again. And so I think that's the way to go.
I'm quite curious about the choice of Java here, because it seemed to us, even though Novamente is coded in C++, for the purpose of internally representing procedures, we'll end up using a language that's extremely Lisp-like, just because it's very simple to represent and manipulate.
Right. I did that when I was at Psychor, of course. Their in-house programming language is Lisp. About half of my experience there was Lisp, and the other part was Java. So let me contrast the two. So Lisp is it's more like a scripting language to me in that it's very it's easy to program. You get immediate gratification as soon as you make a change. Java, however, is the enterprise-ready language, and most of my work consists of pulling other components and put, if you look at the stuff that's on my website, you download maybe 100 megabytes of code. Maybe I wrote 2 or 3 megabytes of that, and the rest of it is library code that's license compatible with what I want to do. And with modern multi-core processors, Java's fast enough for what I want to do. Plus, automatic programming doesn't have to be done in Java. So if I get a system that will implement an algorithm, why not go right to machine language, which ultimately I would do.
Yeah, I guess that's a question of when you're talking about self-modifying code, the approach we've taken is right now the basic AI system is C++, and then the kind of code learning that's done is done in the internal Lisp-like language. Now, ultimately, once the thing has human-level AI, then you can teach it C++ and let it rewrite it into base code.
Well, I think you could do it with less than human level AI. If you look at, people
Most
thought,
humans can't do C++ code.
well, I'm just saying that if you look at if you can bear with me, it's a stretch, but if you can say, well, a compiler's got some kind of hard-coded cognitive ability. I mean, it's a huge deduction machine. Think about all the operations that occur in the compilation of a large Java project, and think about how much mental effort would be if you did it on pencil and paper and ended up with bytecodes. And you can see that the computer's many millions of times better at this than a person. So I suspect it's only an intuition, but that some degree of automatic programming can be done without achieving full AI. But
I think that's true. I think it's just that I was involved with a project, a non-AI project, on this, which you can see at supercompilers.com.
I read your work.
And the thing with that is we're trying to do automatic global program rewriting of Java programs. And when you do that, you become aware of how many complexities and perversities exist in the Java language as opposed to kind of pure Lisp. And I just wonder whether having an AI grapple with those complexities at an early stage is a good choice.
Well, again, you can use a subset of language too.
Yeah.
Some of the use cases I'm thinking about is I would like to be able to ask the system, what's the consequence if I remove line 22 from this program?
So you don't miss higher order functions, for example?
Give me an example.
Well, in a language like Lisp or Haskell, say, you have functions that take functions as arguments, which
Yes.
allows.
Well,
Very-
I mean, you can do the same thing in Java. Just say, well, you don't have closure per se, but you can pass objects as arguments in the object same behavior.
Well, we better move on to something else. We're going to
We will have
debate
this
this later.
discussion offline.
Yeah.
Again, I want to recommend, just as an aside, that I got to know Ben through his mailing lists, and there are several list moderators here. There's the SL4 list, which is a great one, and then there's a couple lists that Ben got going. And the AGI list is my favorite regarding implementers. So if you have some code that you want to implement for general artificial intelligence, I recommend the AGI mail list. Strongly recommend. Any other question? Next question.
There's I'm with the Machine Intelligence Lab at the University of Tennessee, the other side of the state. My question is actually to all three panelists. We've heard, actually throughout the days, we heard a lot of interesting paradigms, algorithms, architectures, but do they truly lie on the path to AGI? So I guess to each of you, do you feel like what you've been sort of presenting is on that path, is going to scale to AGI? Or is it more AI?
Okay, at least for me, there are, I think, different paths to AGI already. So mine, for example, is taking what exists in intelligent systems, living organisms, humans, and trying just to find what is important to them and just reproduce them. So the approach is not really integrative. All modalities are merged and there are no modules. So for example, I believe in this way of doing it, but most of the audience might not. So, but I think there might be other ways to reach artificial general intelligence. So I think every approach presented today might lead to it.
So general intelligence in the sense that we're not solving a particular problem, right? That we're trying to create a system that solves most of what humans can handle. So I think cognitive architectures aim at that, but they may not eventually end up being that. Right? So our approach is to ensure that we're general. We try to concentrate on different domains that are apparently very different, very unique on the surface. So things like language, social cognition, physical planning, or classic AI planning seem different, and by having a system that deals with all of them, it gives us more confidence that it's general in its nature. And so that's one of the heuristics by which we can check that our system is general. And I liked the slide in the morning where they had 4 silver bullets and core values and things like that. So our core value is, so our aim is to develop, find the processes that are essential in the sense that using child development literature to figure out which is already there at an age of 5. So before experience kicks in, what is there that we essentially need? So that might be a heuristic that would help. But I don't know how we would rate something as being more general than the other. Evaluation metrics would help.
If I might just add something, between, for example, when some presenters talked about different modules for vision, for planning and such, I think that during, for example, if we take living animals, there are many similar processes in both systems or both modules. For example, there are integration from low-level elements to higher levels, and all of them have quite the same principles at the bottom level. So maybe there might be some unified way of representing all these different modalities and different way of doing things. So this might be one solution for it.
I think you asked a great question, and I'll tell you why. Because I'm a member of the Association for Advancement in Artificial Intelligence, and I highly recommend this society for anyone who's here. And I would imagine maybe the majority of our members for the AAAI. And I've been to a number of their conferences, and you see one narrow paper after another. Why is that? Well, it's because that's what the sponsors will fund. The DARPA and the government, the civilian side, generally will not, up to now has not been very excited about a large-scale AI, solve the world problem. Maybe they tried that some time ago and it didn't work. But I think now is the time to stimulate interest in it. So my own speculation, intuition, if you will, that today's hardware, especially if you have a small cluster, is powerful enough to do some really amazing things and create the right software. So I would hope that this conference continues and becomes a magnet for papers to be written that aspire. Now it can be narrow, it can be on a narrow topic, but as long as the researcher has a roadmap that has where they keep as their long-term goal, the creation of a generally self-improving system or something that is cognitive. I'll use cognitive plausible because I think it's a useful heuristic in designing such systems. But I think every researcher who presents a paper at this conference or its successors should be prepared to answer your question. How would it be done? Now, they may not tell this to the sponsors, but they should have a plan. When I was at PsychWorld, and I'll tell you how they did it, and I think that's doing the same thing, is that you build an artifact that is a coordinated system that's not to be thrown away when your sponsor's funding ends. Rather, it's part of a continuing piece of work that you continue to augment. And I think SOAR is a real good example of one that's done that. And there are other cognitive architectures that have survived. And by that I mean that you can get incremental funding to improve some narrow aspect of it, but keep the ball moving down the field towards